Hello, I'm back. Well, I was going to work on animation, but I think I just decided to scrap it and just move straight into more parameterization. So I wanted to try something. This scares me a little bit because I've got the feeling this is going to make the material a shitload more complicated, but we're just going to say distortion, whatever. Uh-huh. Alright, here we go. Doop. 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 I kind of got the feeling this is gonna make it way more expensive. But maybe it'll also give us some cool variants. It would be nice to be able to get rid of these static switches for these. Maybe we just keep it for turbulent noise. Doesn't seem to be choking too bad yet. Alright, so now we have to be turbulent for this to work. Oh god. I'm worried about the complexity of the shader when I do this. Say a prayer. This is adding 2 more entire noise nodes to the back of the fucking line and then warping them. It's gonna be... We'll see. We'll see how it runs. Alright. Seems to run pretty good. Okay. I mean, that doesn't feel really particularly worse in performance. Can I still fly around in it? Seems like I can. Okay. Now the big one. Alright, so now let's do the one that adds 4 more types of noise, so it would be an 8 when I do this. Ooh. I'm a little spooked by that. I think it's gonna get real slow, but let's try it. Because if I can get rid of this, this is the last one. And we do the same thing. You just say scalar turbulence warp near interpolate. We stick this here. We stick this here. So sketchy. So fucking sketchy. Okay, so this is substantially increasing the shader complexity now. What's the damage? How complex is it? It definitely makes the fucking material take a million years longer to compile. So with the way it's currently set up, it's adding 4 more noise modes, but as soon as I change this bottom one to also use those warp nodes, it'll be 8 more noise nodes. Which is a lot of noise nodes, actually. Alright, let's see how it works. Close this. Nope. Alright, there it is. So, turbulence alert. What's the performance like now? Still not too bad. We would do a simpler version of this for local fog, but for this can be computationally expensive. Zero, 1, 0.5. I mean, it's working. Okay. Let's do this. The final set of replacements here. Distortion, noise. Cloud distortion, cloud noise. Alright. Surgery complete. We have removed the static switch nodes, so this whole thing should be controllable by a material interface now. Like this. Looks good. This should be 0. This will probably take a while to build. Burn one up. Where's my lighter? Alright. Let's build this motherfucking huge shader. Would I make the local clouds, it'll be way simpler. Like, I'll take this shader and trim out like 90% of the nodes and make it really performant. Like, I would get rid of the stars, I'd get rid of the probably the turbulent noise. Or, I mean, you could still keep the turbulent, like, there could still be static switches for that, but anyway, the point is, when I make local volumetric stuff for giving you texture as you're flying through space, it won't be as complicated as this texture, which is kind of intended for the skybox. I.e., I can turn it on, take a picture, and then turn it off, and it doesn't impact performance after that. Okie dokie, here we go, noise composition. What's going on when I change this? Oh, I see. Distortion pattern's different. Alright, good enough for me. So now I can toggle different types of noise. Cool. And then we just turn the stars back on. I would suspect that the shader cost is very high for this. Alright, so this is our grid. Turbulent slurp. Oh yeah, forgot about this. Cool seeing how the difference between them plays out in real time. Great, okay, so noise composition, turbulence, Fresnel's, colors. So now everything should be developed, able to be used in a. Let's save everything. How does this run if I like run it? Not very well. Oh man, it's heavy duty. Might not be feasible to have the turbulence and the non-turbulence in the same node, the same material. I might have to. Okay, so hold on. Stop. Oh my god, I can't even click it because it's so slow. Stop. Now if I wanted to take advantage of this, I can just do this. Turn off the procedural components. And have a perfectly performant skybox. And we can do all kinds of stuff to tune it. The only thing is, it's very slow. I think I have to go back to a static switch for turbulence.
Alright, you ready to get the trash?
Yeah. Just a moment. Alright, this cuts half the instructions by doing this. A full half. Half of the cloud instructions anyway, not the... Probably less than half, because it still has to do the stars. Alright, I'm gonna go help out, help taking the trash out, and I'll be back in a minute. Alright, I'm back for a bit. Let's see. So, should be running a little bit better now. Yeah, it's not as bad. Let's try running the game. Why is it so bright compared to... Alright. Alright, now here we go. So, next up, to figure out exactly how to make one of these. Is there a quick way to make a real parameter collection from an existing material UE5? Great way to set up and modify multiple materials attribute single input. Check this quick in.
Hey everybody, I want to show you how to use a material parameter collection. It came up in reference to how to make a bunch of things disappear at one time, but it's actually useful for way more cases than that, so let me jump right in. If you go to your materials folder, this is just the demo starter content scene. In the materials folder are all my materials. I don't have to put this asset here, but it makes sense for me, so I'm going to right click, go to materials, and choose material parameter collection. And then I'll call it my MPC, and I'm going to double click it. A material parameter collection is just a collection of material parameters, as the name implies. So let's look here. We have either scalar, single values, or vector, multiple values that we can use here. So I'm going to click on plus to add a scalar value. For this first example, we'll talk about the question that came up, which is how to fade off multiple objects, but you can use this for anything in your materials. So I'm going to hit plus. I'm going to open up my first index here, and I'll give it a name. We'll call this fade. And I'll set the default value to 1 because it's going to be my opacity of my object. And we'll just default it to 1 to begin with. And that's really all we'll do for now. We'll come back here later and show how you could even change colors of multiple things at one time. So, but for now, let's just hit save and close this. So that's my first entry in this table of values, the MPC. Now let's go to, for example, the chair first and open up its material. And let's set this up to be able to fade off the chair, similar to how we faded the character in the earlier video. First,
Oh shit, are you kidding me?
Opacity mask field, so I'm going to go and change my blend mode to masked. And if you recall in the other video, we needed a dither temporal, this little trick to do what we needed in that case. And the input for this, rather than have a value that we just manually have to modify, we're going to grab the value from the MPC, and that's the beauty of this system. So I'm going to right click, and I'm going to type call for a collection parameter. So this means you're going to get your value from that collection. And you have to tell this node what collection you want. Because I had it already selected, it grabbed my MPC. But you can also change it here, or if it comes in and there's nothing here because you didn't have it pre-selected, just click on the drop down and grab your material parameter collection. then you also need to tell it what parameter out of that MPC do you want to use here. And I want to use the only one I have currently, which is fade. And I'm going to wire that into my dither. Its default value is 1, so my opacity at this point should be 1. Save that. So my chair material opacity is going to be driven by
Yeah, this is what we need. This is exactly what I'm looking for, so it's just going to be kind of a pain in the ass. But I get it. So what we'll do is we'll have vector parameters. Where is our material here? So we have 1, 2, 3, 4, 5, 6, 7 colors, and then we have 6 combinations of vectors, so that's up to 13. So 1, 2, 3, 4, 5, 6, and then we have it's literally all vectors, huh? Because this will have to be like, I'll need like separate nebulas for different types of turbulence, I think, based on what I'm understanding and how expensive it is to do it this way. Okay. Am I still using turbulence warp internally here? Yeah, I am. Holy shit. So that was slowing it down.
Hello and welcome back to another episode of 5 Minute Materials, the show where we do the thing and we Today we're going to be looking at material parameter collections. Now this is something that I should have covered a long time ago, but I haven't, so here we are. Now, what is a material parameter collection? Well, after some discussion with the chat and looking on the documentation doesn't know anything. But essentially what I figure it is a collection of parameters that materials have a reference to, and they're just reading values from this little collection of parameters. Now, what does that mean in, actuality? Well, we can right-click, we can go to Materials, and we can go to Material Parameter Collection. Let's call this Tutorial Collection. That's it. You can see we're greeted with a big empty screen. We're just gonna, put a scalar parameter in here called time. Maybe time is a 0 to 1 value or something. And then vector parameters, maybe this is like our sun color or something. Cool. And we're just gonna hit save. So let's just grab a few crates so we can actually make some materials and actually test out what the heck is going on here. So let's grab a new.
Oh yeah, that's way better.
New material. This one's just called.
Oh
material.
yeah, okay. Okay,
Okay,
back in business. I have to run turbulence as a switch because like you have to redo all the noise, and it's just like it compounds in complexity every stage you go up. And I'm already pushing it like almost to the limit.
We're gonna click on collection. We're going to look for the...
Then I'll make a simple version of this that doesn't have the stars and doesn't have a lot of the features, but I can use for a local space.
Let's choose time. So now we have this parameter in our material. If I remember correctly, it was a 0 to 1 value. So let's just put this into a cosine. So in this material, we are just using our time parameter to kind of just do a curve, and it's just going to change the color
Let's
of the
see.
material. Now, in a different material, we can use that same time value
Oh,
to
that's-
do something completely
that's really
different.
cool.
So maybe we want to make a crate explode slowly over time. I don't fucking know. Let's just get vertex normal world space multiplied by 40 multiplied by this time remapped value, blah blah blah. Chuck that into the world position offset, and we hit save. And let's just apply that to this crate. And so now, if we go to our parameter collection and we change this time value, it's going to be doing different things on these two different materials. So these parameter collections, usually they'll get used for global variables, like your time of day, maybe like the player's location, whether it's like raining or not, and all that kind of stuff. Obviously, different materials are going to react differently to, those variables. So in a more practical sense, things I use this for is stuff like the wind amount. So as we ramp up our wind intensity, you can see that these trees all get windier. Their leaves will start shaking more.
Oh my
will
God,
start
this is
bending
so
over in
perfect.
the wind, and this happens to
This
all
is
of
exactly
the
what I
trees
need.
in the scene. But you can see the grass down here reacts differently to how the trees react. We can also use it for things like the rain and also the overall wetness of the scene. So you can see here when it's raining, I'm just gonna change this value so that everything becomes shiny, and this pitter patter happens. And these are things that are global to the entire scene. Now, if I wanted to exclude this from a mesh, I'd have to specify that in the material. I can do that currently by using vertex paint. So that's like one of the ways that you can kind of exclude on parts of a mesh these kind of global variables taking effect. If you don't know what vertex paint is, I've got a video on it. You can search it up. Another thing that these parameter collections are really useful for is for changing those kind of really hard to access variables. So if you've ever worked with like post-process materials and light functions and that kind of stuff, you'll know that you have to like create a material dynamic instance and set a reference to it, change the variables, and blah 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 blah. You can reference these material parameter collections inside those types of materials. So for example, I've got like this skybox, and when I change the cloud density, it's just referencing that in the skybox material. Conversely, it also changes the cloud texture coverage in the light function, which is on my directional light. So you can see as the cloud density goes to 100%, then the directional light is completely obscured. If we put that back down to 0.25, then you can see we've got these clouds kind of rolling overhead. Very, very cool, very spicy. We also use this in our post-process. So if we go to our fog opacity, so if we put fog opacity to 1 and we put the fog distance up, then you can see that we're altering some values in the post-process just by using this this material parameter collection. Now this could also be used in materials in the world. So maybe we have some kind of monster that is only visible when the fog value is really high or whatever. So you can basically access these values anywhere in any material and do whatever you want with them. So with this little setup here, we've got the time of day, basically when it is nighttime, it's going to be doing a thing. And then also when it is foggy, it's also going to be doing the same thing, which is just going to be glowing really brightly. So you might use this for lamps or torches or something around your scene, and you don't want to have to switch them on with a blueprint every time, every update or whatever. So in this example, let's put our fog up to 1, and you can see that this is now glowing really brightly. If we get our time of day and just switch it to be, nighttime or something, then it will be glowing really brightly. If you wanted this to just be like an on-off effect, then you could just add some contrast, do some math So we could do some math like contrast, just keep contrast with a value of 100 or something. We could even do that post max, which is just choosing the higher value. And so now if we have a look, then there will just be a point, which is 0.5, that it will just turn on. So yeah, again, this might be really useful for like street lights or something, and it can just kind of eliminate the need to manually update things. So if we want to actually change or update values in our material parameter collection, all we need to do is go set scalar parameter value, and it'll say collection here. That's how you know you've got the right one. You just click that, get whatever collection you want to update, get whichever value you want to update. So let's say it starts raining, and I gradually want to, change my rain parameter from 0 to 1. Just do some math and some, a timeline or something. Alternatively, if you want to use a vector parameter, it's just set vector parameter value. And again, make sure it's got collection there, and then this is your linear color input. Same thing as this one. Now you can also get these parameters, so get scalar parameter value. You can get this from the collection and do whatever you want with it. This can be really handy if you can't be bothered sending these variables explicitly, like from your time of day manager to whatever. You can just kind of grab it from here. Now, I don't know if this is best practice or not. I don't know what the cost associated with getting these values is, but I'm guessing that there is a copy of it on the CPU and the GPU at any given time. I don't know. Just, it's there if you need it. So in my case, I've got this in the construction script to update, some stuff. If we just go into this blueprint, you can see on construction, I'm just calling this event, which is the time update event. And essentially what it's doing is just, getting the time of day and then putting that every time we update into this parameter collection. Same thing goes for the rotation, like angle of the sun. We put in the sun's position vector as well. And then we also update the atmosphere color, which is like my kind of fog system, and also the fog color. So again, you probably see if we made it foggier. So we chuck the fog opacity up to like 0.8 or something, put the distance up a little bit. As you start to change the time of day, it actually changes the color of the fog. So there's a lot of ways you can kind of get these variables to all like interact with one another, and it can really just help add a lot of consistency to your scene as well. Now, there are a few things that I think this is kind of, it's not like inappropriate to use for some cases, but I do see some people using material parameter collections for like color palettes that are all, like they have like a grass color in the material parameter collection. Which, there's nothing wrong with that if you are updating that same color at runtime. I don't know why you need to change it to a specific color, for everything. But for something like where you've got like a specific grass color that you just want to put on materials and stuff, I'd probably use a material function that has that in it, because it'll be more performant, because, a constant value can just get kind of optimized into the shader at compilation time, whereas a parameter that is expected to change has, some kind of small cost overhead. What I would recommend doing, however, is having a value for like your seasons, for example. So let's say you've got, winter, spring, I don't know what the order of seasons is, but let's just say it goes from 0 to 1 and like repeats. So what you could do in your shader is, let's say you want your grass to change to some specific colors in specific seasons, but then you can also use that value for different things. Like you could make the opacity of your leaves go to 0 in winter. So rather than having a million different color values in your parameter collection that you have to kind of keep track of and stuff, just have one value called season, and then decide what to do with that value inside the shaders. So that is the material parameter collection. I hope that you learned something new today. I hope you find this very useful as well. I know I found
Okay, so now how did I use it?
collection. we're going to look for the tutorial to give it some default values. Maybe it's a purple crate.
Alright, so now we will clone our good texture. Rename it to and then go replace all the inputs with the shit out of this. And then I should be able to like easily change the settings at runtime. Okay. Start way over here. Okay, so how did he do that?
Parameters, grab a few material. We are going to look up collection parameter. Now you can see it says unspec. Specify. So down here, we're going to click on collection. We're going to look for the tutorial collection, bam. And the parameter that we're going to choose is, let's choose time. So now we have this parameter in our material. If I remember correctly, it was a 0 to 1 value. So let's just put this into
Oh my god, this is insane.
cosine.
Okay, so okay, so first of all, before we do this, I need to set defaults. This is insane. Exactly what I wanted to be able to do. Okay, so now I gotta set the defaults here. So where's my material instance as I have it right now? Here it is. It's over here. Transcribe the values. 0.01. Okay. Cloud. Point 0.01. 0.5. 0.01. 1. Okay. Mask noise. Mask is 0.01. 0.5. 0.01. 1. Mask and cloud are set. Combine noise. 0.1, 10, 1, 2. I don't have any dither on right now. Gross. Oh yeah, that's better. Okay. Okay. Noise composition is a 1111 right now. Oh shit. I fucked it up. Gotta go back here. So cloud noise is set. No, wait. Combined noise. Cloud noise, yes. Mask noise, yes. Combined noise, yes. Composition, yes. Starfield, here we go. 0.998. 0.17. 1. Okay. And now for these, I can just copy, paste. Could I have done this? So if I take this back down here, could I have done this for these? Copy, paste, paste. No. Doesn't quite work that way with those. Okay. Okay. So now we just go. Can I split that struct pin? I'd like to be able to spread this out. We'll just, okay. Alright. Like thus. delete this. You may want to, we're almost certainly going to be reusing this construct right here of the breakout append mini. Okay. Wait, I broke something. Or was it broken before? It was broken before. Don't crap out on me, game. You can do it. Okay, nice. Now, now it's like a godsend to be able to do this. Okay. I wonder if I can make like a material parameter collection instance. That would be nice. Probably not. Okay, I need like just one of these on the side to copy every time I start a new one. And actually it needs to be this. Alright. This one is noise composition. I'll just do this. Okay. Surgery's complete on that. bring this little guy along with me as I go systematically replace all of these connections. Okay, this is Starfield. And we're going cha. Okay. Okay. There's another one down. This one right here. I didn't add controls for the Fresnel. I'll leave it like that for the moment. So what do we have left? We have 7 colors. And for that we're gonna need a bunch of these. The output of this, yeah, it's float 3s. Okay, so I also want this. Actually, let's just do this. I'll make the node for the colors. And then we'll clone this. 1, 2. 3, 4, 5, 6, 7 times. And then we'll just start replacing. This will be star color 1, RGB, steal this guy, put it here. This can be star color 2. Steal this guy. Color 3. Oops. Right. No. Alright. Now we have to do something similar up here. Alright, cloud color 1, 2, 3. No, 3. Kill all these. House cleaning. Do I have any remaining parameters that I want to control externally? I don't actually think I do. I think I rigged everything up. Alright, let's give this puppy a shot. So, oh, fuck. Alright, let's give this a shot. So theoretically, if I apply this material, it should look exactly the same as the one I have right now. But then I can control it external to the material. So instead of having a material instance like this that I can fuck around with here, it would be like I mess around with the material interface to change it. Alright, let's give it a shot. So I need to go to my Niagara system. Alright, let's try it. So we've done that. Oh, I think we've done it. Alright, so now if I go to my parameter collection, also, how do I set defaults in default value? Alright, well, let's find out. That's fucking cool. Alright, so we have dynamic. Have the ability to dynamically update our shit now. That's good. It's gonna be a little bit more of a pain. Can I wonder if I can bind like a different material interface? Like that must be what that was talking about in the Niagara system here. So what is this? Oh my god, this is crazy. Okay, so this will be the interface. And then we can just so now it's obviously chugging. I can't do anything right now. Okay, so we successfully parameterized this awesome material we made, and now we can we're not very far off from being able to make really high quality procedural skyboxes with all variety of colors and patterns and nebulas and such. So that's nice. So let me see something now. In my scene, if I pick this, can I create an instance of this material interface now? Or something along those lines? Wait. Are you kidding me? Is that fucking simple? Woo! Alright. So now let's see how he modified this in a blueprint.
Fine. So, if, in the, without, or, get.
So, hang on. Also, I wanted to check something. So now that I have this particle material interface, if I was in... say that blueprint again. And I have... this here, and I take this and I do set Gara and I were to call this particle material. I'm going to actually rename this. And then I came back over here and I said and then I create a T well, that's pretty easy. to get Nyara from system object is from component go. Yeah, it kind of gets rid of the need for all of these, right? If I can just set the material. Okay. Let's see. Okay. Master material's done. Both versions of it. Okay. Trying to think of what the next step here is before I get too deep down this rabbit hole. So I have two ways to do this now. Cast to object. Child component. This is it. I think this is it. Never mind. Yeah. Okay, I'm just gonna look at how to change it in the fucking video because I already set up the NPC texture. I might as well use it right.
These parameters, so get scalar parameter value. You can get this from the collection and do whatever you want with it. This can be really handy if you can't be bothered sending these variables explicitly, like from your time of day manager to whatever. You can just kind of grab it from here. Now, I don't know if this is best practice or not. I don't know what the cost associated with getting these values is, but I'm guessing that there is a copy of it on the CPU and the GPU at any given time. I don't know. Just, it's there if you need it.
It was this.
So in my case, you know, I've got this in the construction script to update, you know, some stuff. If we just go into this blueprint, you can see on construction, I'm just calling this event, which is the time update event. And essentially what it's doing is just, you know, getting the time of day and then putting that every time we update into this parameter collection. Same thing goes for the rotation, like angle of the sun. We put in the sun's position vector as well. And then we also update the atmosphere color, which is like my kind of fog system, and also the fog color. So again, you probably see if we made it foggier. So we chuck the fog opacity up to like, I don't know, 0.8 or something, and put the distance up a little bit. As we start to change the time of day, it actually changes the color of the fog. So there's a lot of ways you can kind of get these variables to all like interact with one another, and it can really just help add a lot of consistency to your scene as well. Now, there are a few things that I think this is kind of, it's not like inappropriate to use for some cases, but I do see some people using material parameter collections for like, you know, like color palettes that are all, you know, like they have like a grass color in the material parameter collection. Which, like, there's nothing wrong with that if you are updating that same color at runtime. I don't know why you need to change it to a specific color, you know, for everything. But for something like where you've got like a specific grass color that you just want to put on materials and stuff, I'd probably use a material function that has that in it because it'll be more performant because, you know, a constant value can just get kind of optimized into the shader at compilation time, whereas a parameter that is expected to change has, you know, some kind of small cost overhead. So what I would recommend doing, however, is having a value for like your seasons, for example. So let's say you've got, you know, winter, spring, I don't know what the order of seasons is, but let's just say it goes from 0 to 1 and like repeats. So what you could do in your shader is, you know, let's say you want your grass to change to some specific colors in specific seasons, but then you can also use that value for different things. Like you could make the opacity of your leaves go to 0 in...
Alright, I'll be back in a minute. I'm going to sit inside the pretty nebula in the meantime. Here we go, here we go, here we go. I have some ideas now. So, first I gotta figure out UE5, how do you update NPC tears from Blueprint? Please tell me. Actually, you know what? This is a perfect question for our new coworker, because I think that this is something that he actually will be able to help with. It's not as complicated as some of the other shader things that didn't quite work out. Although he had some good ideas. So let's try this. How do I update material parameter collection from a blueprint UE5? There we go. Set scalar parameter. Wait, hold on. Create a reference to the material parameter collection by right-clicking, selecting Create Material Parameter. Did it? There is no option to create. Wait. Can I just? Yeah. See an option to create material parameter object. Create material parameter collection is not an option in the blueprint context menu. Is this the one I need? Okay. Yeah, that's not right, but I will get this. Well, sorry, coworker, that wasn't amazingly helpful. Though some of your Perlin noise advice was good. Okay, so let me find a video. Not quite gonna replace me. Not quite yet.
Some, a timeline.
Set scalar. Set vector parameter value collection. Ho 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 ho. Okay, so now we want to create an adapter. In order to do that, we can go ahead and collapse the function, and we'll call this alright, here we go. This is going to be Nebula Need 13 of these bad boys. That's 12. Alright, so what are we doing? I'm creating an adapter to expose all of this stuff in one node to make it easier to externally manipulate. And so what we can do then is let's open up our material instance so we can order this the same way again, because that is handy. And we can just go UV offset, cloud noise, mask noise, combined noise, noise composition, star field, and then cloud color 1, cloud color 2, cloud color 3, star color 1, star color 2, star color 3, master 10. Alright. So now over here we need to add oops. Okay, that's what I thought. So I need 1, 2, 3, 4, 5, 6 of these in seven linear colors. Double for value. Oh no, these are local variables. Wrong. Shit. These should be inputs. Double vector. Thinking if it's going to be easiest to work in these or break them out into single values for an adapter. I think they're fine as double vectors. We'll give them the same names too, so 4, 5, 6. And then another one, but this one is a linear color. I get 7 of those, so 1, 2, 3, 4, 5, 6. Alright, we can copy, paste, no. Display name. Copy display name. Should honestly be the material parameter interface that I'm going from, huh? Alright, let's make it match here. Eventually I'll go back into the that didn't work. There we go. Almost there. Alright, now the next question is, can I... only execute blueprint function step if the input is connected. Let's ask the coworker. This is a coworker question. Okay. Can I write a blueprint function in UE5 that will conditionally perform steps on which inputs are connected? Not exactly what I'm looking for. I want to create and update a MPC. But I only want it to update relevant MPC field if the input node for that field is not string. Is input valid? Is input bro, there is no input valid node. Wait, maybe. Some how can I check if a blueprint function input parameter being set externally versus just being its default value? Okay, he's stumped now. I have to do this. 35. There we go. That's what I wanted. Is valid? Booyah, all right. How do I do a validated get? Coworker. How do I do a validated get? Alright, delete this. Delete this. Here's what we'll do. We'll change it. We'll do default values. These will be zeros. These will be zeros. Only if like every setting is 0 will it ignore it. Which I don't think would ever be the case in any of these. But we'll see. And then we can just do delete this. Default DVP. Default LC. This is going to be linear color. Default linear color add 0, 0, 0, 0, 0. Perfect. Default this 0, 0, 0, 0. And then we just say coworker, is there a fast way to I swear, like, I don't understand what he means when he says drag the parameters. Like, the parameters are right here. And you can't fucking drag them. Like, what? Maybe he means dragging it like this? Okay, that's probably what he means. That's gotta be it, right? Not context sensitive. Okay, fuck that. We'll just do this. Fast way to compare test two double vector parameters for quality equal vector. Yeah, you actually can't. I don't know, here we go. Boom, got it. Alright, we're good. So we just do this. Flow 4. Equal vector, okay, so God, so we're gonna have to do this. Yuck. These are not what I thought they were. Okay. Okay, thank God. And then we just go through here and do. And then linear color should be correct. Okay, thank God. So now. Sequence. Alright. Now we got our template to do this. So we basically need a shitload of these. Alright, well, let's get these rigged up. So down here, you go here. We're just gonna do this. Here. And what we're basically doing is following like an adapter layer pattern to expose the contents of this function library. Shit. Well, shit. Everyone's transparent. Alright, so even better, we need even less. Here, here. Okay. Now I got default linear color. Yeah. Shoelaces. Alright, and now we just finish connecting these and these and these. And these. There. Now, finally, noise composition, star field, cloud 1, cloud 2, cloud 3, star 1, star 2, star 3, tint. Okay, great. So now I have now I have a material function that basically functions as an adapter layer over our material library, or our material collection library. And this makes it so that if I want to say, don't need any of this actually, but what we do want to do, let's ask the coworker something. In a blueprint, how can I work between two linear colors over time on a sine wave? Or time. There's the alert. There is no time node. You have to use the event tick, but I forget how to make it a regular, and I forget how to enter. UE5 warp between two alternating colors. Over time.
Hey guys, and welcome back to compile, save that. We're going to add another variable, this once again being a linear color. All of the variables we're going to make this fine for me. Then it's going to do the rest of it. On event begin play, where you are creating a widget and adding it to the viewport. Also just right click return value and promote it to variable so you have a reference to it here. Because again, color to be what the new color that first we want here. Or simple part, actually setting up colors.
This is terrible.
So to me, the
Just
top
give
one
me
is-
a fucking. Use the event tick. Use scale. Okay. I think I got it. Set time. Um, fade between two. Two. Sorry, I'm just trying to figure out how to do this.
we can just do this. Font. No. No, no, no. Blue.
Hello, fellow Unreal Engine games developers. It's applicable as well. And then I can specify how often I want to execute it, or how long to wait before executing it. So let's do it every second, and looping. So if I don't do looping, it'll just do it once after a second. If I do looping, it will do it every second. There are some other functions we'll show a bit later on in this episode. So this now will execute the spawn table function every second, looping. So if I go into play mode, we get the same number. This time, in or near the event that it's calling. I'll show you the strategy I use, and see if you agree that it's more maintainable. So I'm going to disconnect this event here. I'm going to create a bit more space in this comment, and I'm going to drag down here. So now we have the set timer by event right beside the event that we're calling. And what I'll now do is I'll create another custom event, which I'll call start spawning tables. So this is a sort of a shape that I have for anything where I have timers, where I have a start spawning tables event that sets the timer, and this is the event which happens on a regular occurrence. And now all I need to do is call this event from the begin play. Up here, I'll do start spawning tables. That calls this event, which sets the timer, and then the spawn table happens. But now it's much easier to see when I come back. Oh, I've got a start spawning tables event, and then it sets a timer, and this is what happens. So if I press play, same as before, everything runs successfully. But I've got.
All right, let's try it out. Save this. Make sure that our NPC is set. It is. Let's turn this visibility off and drag this in the scene.
When you're using timers, is you might want to you might not want to call an event, you might want to call a function. So over here we've got this function, print random integer. I'll just open it up for you. And you can see that it prints a random string between 0 and 1000. So maybe that's what I want to call in my timer every second or so. So let's go back to the event graph and look at how we might do that. Take out the spawn table, and again let's do set timer by event. And we haven't got anything we can connect this to. There isn't. You can't connect to a function. So how do we do it? Well, there is this node called create event. It's quite obscure.
There it is.
Using it. So if you do create event, it allows you to not only select events in the drop down, but also to select functions as well. So if I select print random integer, you can even select event, the object here itself. You can even have events or functions that are in another object, as long as you have the reference to it. So this allows you to set a timer.
All right.
Second,
So now we have the ability to change this on the fly with values that we calculate in a blueprint. I think that's a pretty good amount of progress for tonight.
see at the top left.
We gained capabilities here.
Between 0 and 1000.
Oh wow, the fucking
Let's see what happens if we change the function name, because we always want to think again about maintainability.
stop.
So let's say that somebody comes along later on in the development
Now
lifecycle,
wait a second.
changes this print random integer. to
BP procedural nebula.
They don't know there's a timer on this, so do this. You can see at the moment we've got this error here. When I compile, it seems to have resolved the error. So print random int, it's a selected function that ties in with this.
Oh yeah. I know what's up. So what's my Niagara settings out here?
And
These need to be
this
the
is
defaults,
bug,
actually,
expected
but-
bug, actually, because I would have expected this to work. But what happens is if you then select print
Okay,
random
so
int
interview
again,
port, we
you
picked
drop down
this, we
print
set our
event,
default values.
and then go into
12,
play.
oh yeah, this is way too big. 10,
However, that is an issue
10.
because if you change the function name, you didn't change the create event in time.
100, we'll try that.
This is why something isn't working. So,
And then
be aware of that. If you want to use a
zoom in
function,
on it.
I would probably do something like this.
Yeah,
where
let's
we create
file.
add a custom event called print random. Then I would call
I may have
function
to,
print random
I
int,
think I actually have to do this.
and then I would connect that to the event. So now if I change
There we
this
go.
function name, that will change here. If I change the event name, that will change and nothing will break. So check that out. That bug may go away in future releases. But if you're using functions, it might be safer to do something like this. Okay, I've opened up another level now because I want to show you a couple of other parameters of the timer and what you can do with them. So in this level you can see I've placed 6 of these half pipe meshes in
All right, we got there.
blueprint. And I want to rotate them on a regular interval. So I don't want to use event tick, I want to rotate them a certain number of times.
We got there. Oh shit, dude. I didn't even see that you were talking in here, dude. I've been like zoned out doing this shit for a while. Under Miss Curve, you get an option to make it a color curve. Use a timeline to get any sine curve in there you want. You may linear color curve. Yeah, I could definitely use a curve. This is literally just a proof of concept right now. So I created this nebula texture that you're looking at, this volumetric shit. Oh my god, it's too fast. Camera's so fast. But I created... Maybe. Oh, right. That's the problem. Maybe? One time? Okay, there it is. Ooh. Gotta turn the camera speed down. Holy shit. But anyway, yeah, I created this volumetric that I'm going to use for skyboxes. Obviously, it's slow as hell. But I only need it for a second to snap a picture. But the settings are all wrong. So I'm working on that. But the looking to do like a smooth transition was really, I just wanted like a proof of concept that I had properly built out this adapter right here that updates my material parameter collection. So like I built this adapter with checks against 0, 0, 0, so it like won't try to set the value if it's not set. But using this, I can update every parameter that's being used to build this effect at runtime, which is going to be used for like I said, randomizing skyboxes. And then I'm going to clone this and make a way simpler version that's way less expensive. And use that for like local area fog so that you get like a sense of speed when you're moving through the scene. But I'm just trying to get this locked in here. So basically, the fact that this is working means I'm pretty much there. So I'm going to delete this and put my procedural nebula in here. And then this guy, I think there were some issues with his nebula settings. Yes. So in this nebula particle system, I built the ability for it to take a mesh. So for instance, I'm going to use this donut. But I could potentially provide this with a big array of meshes and have all different shapes and configurations this could be in, and just swap the mesh out when I'm randomizing the nebula parameters. So that's also kind of on the radar. But let's go ahead and back up. So the reason, like, the stars obviously wouldn't work for like a moving scene, but you can turn them off for local fog, and then it works pretty good with moving. But they look really good in SkyMap and in Skybox captures. Okay, this is not big enough. So what size? I think we need to go in here and make, I think I was at like 5. Yeah, there we go. Now we're talking. And so then I can just turn on another sphere that provides some more underlying background color and stars for the non-nebula parts of the sky. And when I randomize the 3D shape that this is basing this particle system off of, I'll be in good shape. Okay, and now that it's the same size that it was before, I can speed the camera back up a bit. Okay, so now I can see, oh, my colors are changing in real time. So cool. And the colors changing in real time is cool and all, but what's going to be really cool is when I start randomizing the ranges of the noise parameters that are going into the different types of noise that are being combined to make this effect. And then you're going to get not just different colors, but different densities, different shapes in the clouds, different kind of distortion and stuff like that, because there's the material is this guy, which I've rigged up to this MPC, material parameter collection, but the one that isn't that it was based on is this. So if I take a look at that, you can see how it's tunable. If I can find it. All this shit is super disorganized. I need to organize all these, yeah. So you have world position offsets for the effect, like all the noises, and the master scale that will blow up the noise or shrink it. You have distortion scale, distortion power, noise scale, and invert
inversion warp for the clouds. You have distortion scale, distortion power, noise scale, and invert warp for the mask, which is being used to like mask out large, like contiguous chunks. You have extinction, so I can't change the other one because it's in the NPC, but you have extinction, multiplier, exponent, and dither for noise. You have mask distortion, so like this is toggling between different types of noise. So I have two types of noise I use simplex and Voronoi, and like these toggles basically lurk between the two different types of noise for each node. So the mask is made of the lurk between simplex and Voronoi for this. The noise for the mask, the distortion is this, the noise is this, the cloud's distortion is this, the cloud's noise is this. And then finally, you have these star parameters, which are used to basically turn on and off the sparkling stars effect that is used for capturing sky maps. And obviously I have to figure out like good parameter ranges for all this stuff so that I get like consistently good looking results. But that's just a matter of like, that's why I was thinking, that's actually what made me think about the sine wave idea, is if I can create an animation that runs a sine wave up and down between two numbers that I provide it, then I can very easily visually see the ranges that look good by just fiddling with the minimum and maximum range that it's like oscillating between and watching it like fade between those colors. And then I get, like, for a given parameter, I get to, in a short period of time, see the full gamut of possibilities that I'm thinking about assigning to it as a randomization, and very quickly see if like I'm exceeding any ranges that like fuck it up and make it look bad or anything like that. But my intent tonight was basically to get to the stage that I'm at right now, which is being like, when I started out, I wasn't able to do anything to this at runtime, and now I have it all controlled by a material parameter collection. It's very easy to fuck with at runtime, so that's cool. I also, like, I made this skybox texture really, really early, and I just kind of slapped it together. And I think I can probably do better on the background skybox effect. I really want more of like billowing, like low contrast, low luminosity clouds between different colors, but like near black, near purple, near blue, you know, like it needs to be like very close to complete black, which is kind of what I'm doing here, but this is standing out a bit much. I would rather shape that kind of stuff out with the nebula texture when I get the randomization fully going for that. But this is a huge step. Just being able to like mess around with the colors is way further than I've been so far. And this is going to be a super useful node for the randomization, because like basically this wrapped with one more function, one more adapter layer, taking a set of randomized high-level conceptual nebula ideas like composition, temperature, density, stellar density, things like that, and then figuring out how to convert those into these variables, and then I can just randomize a nebula with a certain composition and a certain density and certain like other features, and have all that stuff get adapted into parameters here that make sense. And then you would even have data about your nebulas like available to the user, like this is a blah 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 class nebula, it's made of this stuff and that's why it's this color. Yeah, so like this is something I've been working on for like probably 2 weeks now, just this kind of effect. And it's coming along coming along pretty good. So again, for instance, like this color right here, right? This is the default star field parameters. So say I didn't want the stars. If I turn this to 0, I don't have stars in the nebula anymore. If I turn this to 0.5, I'm decreasing the luminosity of the stars. 0.1, 0.1, etc. And you can do that for all of this shit. This one you probably don't want to fuck with too much. It's like you can get real ridiculous real fast with the stellar extinction. Like if it goes much under like 0.995, which is a really tiny value, it starts to look bad. 28997. But here's the fun part, right? So say I wanted to. Here, this is a good one. So I have proper extinction functions now. So if I want more sparse nebulas, I just have an extinction function that ranges between 0 and 1, and usually by the time you hit like 0.3, it's all gone. Right? But all of this is going to be able to be randomized. We'll do 0.1 by default. Or, I can increase the brightness of what hasn't been extincted. Or say, where was my combination? I can't talk good. Composition here. So, noise composition. So like if I wanted to, so I have different types of noise that can be worked between. So this is full Voronoi noise. This is full simplex noise. And then these are going in between combinations between the different types of noise. So you can get a lot of variation this way. Let's see, what else is cool in here? Master scale is pretty useful. So like if I like this effect, but I just want more of it, I could do like that. If I like it, but I just want less of it, I could do like that. It's very easy to control the master scale. You just can't get much bigger than like 0.01. Or it starts looking bad. It's all determined on how big this is in space too. Like if this was smaller, then larger world scale values would be fine. Alright, well, yeah, about 2 weeks. I mean, like, I just do this for fun, so, like, I just bash my face on it for 2 weeks and eventually wind up on this. But, like, the thing is, like, it's not about the amount of time it takes you to get there. It's about how much you learn along the way. So, at the end of this project, I have a better understanding, or not even a better, I would say I have a good understanding now when I didn't before, of all the noise functions in the materials, of not only what the noise functions of the materials do, but like on a more theoretical basis, good ways of manipulating and combining different types of noise, like effective ways to combine them, effective ways to work between them, and things like that. You could translate that knowledge into generating like procedural cave systems for like a cave digging game. You could translate that knowledge into generating like voxel planets that have cave systems and overhangs and things like that. So I don't really look at it as like wasted time or like taking a long time to do something. I just look at it as more shit that I can learn, you know what I'm saying? All right.
I do think that's going to be it for the night. I got really far with this today. I think tomorrow I can probably complete the randomization layer to where I can just feed this thing a seed, and come out with a nebula, and that'll be really cool. Oh, and the other thing that's fun is, since this is material parameters, I already know kind of like how I will determine these. What I'll be able to do is, so eventually this time when I build my procedural universe, I'm going to use Octree, and I'll be able to have the nebulas occupy a higher level of the Octree than the rest of the like planets and stars, like a couple orders of magnitude up. And then what I can do is, instead of determining... Oh, nice. Yeah. I was actually looking into AI audio generation for like just some like low res or some like synthy kind of space music. But yeah, so I'll make it an Octree. I'll have the nebulas live in a higher order, like a higher, I don't know what you would call it, but like a higher tier up in the tree than the planets and stars. And then, depending on where you're at in the sub nodes, I can lerp between the material parameter collections from like your surrounding higher order nodes. And then when you move through space, hopefully, you should also be moving through like the nebulas in the correct way. Like conceptually, because this nebula is defined by noise that takes its world space coordinate as its UVs. So basically, you're defining a pattern with noise that just like exists in the space. Oh yeah, man! I've been doing all kinds of stuff. I'm starting to integrate like chat, like not just at this, at work too. I'm starting to integrate like ChatGPT into workflows. I'm starting to integrate like I don't want to get left behind by all this AI shit, dude. I want to be the person like harnessing the AI to like fucking get ahead, not the person that gets left behind. So like fucking learning all that shit. I picked up a ChatGPT API key as well, so I'll probably play with that at some point. Completely I mean, it could be Unreal related. I guess you have C++, you could make a game that theoretically makes requests to ChatGPT for things like dialogue from NPCs or something. That would be insane. you create like random NPCs, tell the ChatGPT, come up with a name and a personality as its first prompt, and then you use the output of that prompt to basically say, okay, you're this, here's what the user asked you, what do you say? And then just have the AI like provide conversation in the game. That'd be kind of fun. I think that it would be... I have some ideas in that space as well. Like, I would like to integrate something like Midjourney and ChatGPT to create something that will just write you a storybook and also generate illustrations for the storybook. Just like you give it a prompt and it like spits out a kid's like illustrated storybook or something like that. I think that would be a fun project to undertake. Unrelated to like just ignoring Unreal Engine, just a fun programming project. Dude, it's fucking insane. I've been using it the past few days, and like it's dumb sometimes, but I received several insights on how to properly process the Perlin noise, and so it's really good for stuff like that, like kind of obscure or arcane knowledge that's not insanely complicated. But also, at the same time, here, let me bring it up. And sometimes it'll give you good advice, and sometimes it doesn't. But like here is telling me to do some shit that doesn't exist. Like, it was telling me to use a time node in a blueprint. There's not one, right? But if you wanted to write you... Oh, here's perfect. Write me a C++ struct representing a planet data model. Right? I'm going to use this when I go into my, like, generating my universe model this time. There's no reason for me to come up with that shit myself. I'll use this. Let's see. Look at this shit. Do you see this shit? This shit literally scares me, dude. Add more detail. Yeah, exactly. Anything like that. But the thing is, dude, like, this is something I thought about recently, is like, fucking Zuckerberg thinks he's gonna create the metaverse. Fuck. We've been in the metaverse basically since the fucking internet was adopted on a widespread fucking basis. Definitely since everybody has a fucking smartphone in their pocket. Yeah, exactly. And like, it's like just fucking arcane fucking knowledge. It's good at like kind of corralling that. Like, it was able to help me figure out how to properly basically create clumpy masks out of noise. Lots of stuff like that. So I not more descriptive detail. Add more parameters to the struct itself to create a more detailed planet data model. Telling you, dude, this shit is spooky. Ah, yeah, see, this is more like it. See, like, I wouldn't use all this, but using this to generate ideas for things like this is insane. Because you don't have to go do the research yourself. You do this, you keep telling it to add shit, and eventually it's going to be adding stupid shit to it, but you just keep telling it to add shit, and then once you have enough shit, you look at it and you're like, I can use this, 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 I can use this. I don't really care about this. This will probably be the relationship will be the other way, and I don't. This might actually be relevant, and then you just go make that struct, right? And like, I don't have to go figure that shit out. It's ridiculous. Okay, now continue to add more detail to the data model. And this is 3 too. I haven't even fucked around with 4. I'm literally on the verge of subscribing to the service. I think is that useful. I've been using this shit for ideas at work too. I mean, I don't use it to like directly code, but if it's just something mundane. Especially like if you're dealing like, oh man, dealing with like NPM shit, or like just shit that's just like fucking mind numbing, like package management or fucking stuff like that. Oh, this is super friendly for that. This is not bad, right? I could use it. I could use the API to generate the names of my planets procedurally. You know what I'm saying? Like, there's all kinds of stuff you could do with this shit.
Mass, radius, num satellites, habitable, surface temperature, atmospheric pressure, semi-major axis, orbital period, rotational period, gravity, escape velocity, albedo, and axial axial tilt. That model is almost right. Let's remove albedo and escape velocity. So when I go, what I'll do to build my universe, yeah, dude, it's this is like we have some interesting times. The next decade is going to be interesting. Let's put it that way. This will surpass us. And it's not even going to take that long. Right now, it's beginning to surpass us in individual focused areas. But eventually, someone will marshal all those individual focused areas that it's better at than you at, which is anything that the internet could potentially be better than you at, which is everything. And somebody will build another AI that marshals all that shit together. And that's when it's gonna get... That's when it's gonna get real spooky. Real spooky, real fast. I don't know, man. Shit's insane. This shit documents the shit better than I do, too. God damn. Let's see, so... This is a pretty good Planet model, right? Yeah, yeah. They just opened up GPT-4 to have the ability to browse the internet at will, so that's nice. Like, rather than feeding it a training set of the internet, they just open it up to, like, continuously look at the internet. So, that'll be interesting to see what comes out of that. And, like, all the art shit, like, I feel so bad for artists. Like, I mean, shit, I paint and draw and shit. Like, I don't fucking, like, oh, man. And music, like, whew. I was talking to my wife. This is where I think it'll be. In, like, less than 2 decades, you'll be able to, like, say you have a show that you want to see, but you've seen all the episodes. You'll be able to go to your TV, and you'll be able to just tell it, hey... I want to see a brand new episode of Price is Right, but from 1987. And it will give you an episode of Price is Right that will be indistinguishable from an actual episode of Price is Right that happened in 1987, except it will not be real. None of the people on it will be real. And you won't be able to tell the difference. So, there, bam, you get a struct right here. Like, this is not even, like, I'll save this. Like, I don't need the, like, actual C++ code. But when I go to make the struct, there's my planet. Yeah, dude. Basically, that it, like, basically, yes. I don't know how fast the fucking, like, brain computer interface will come along. I don't know, dude. Like, it's all who knows which direction we go. That could be an optimistic take on it. I'm curious if we're gonna go down an optimistic or a dystopian path with this shit. So, like, yeah, so when I go to generate all my shit, like, oh, you know what I could really use right now? Because I was thinking about doing the randomization tomorrow. Let's check in with our coworker. Hey, buddy.
Okay, now make a data model of a nebula. These are string arrays, but whatever. See, this is already more shit than I would have thought of, right? Like, I wouldn't have thought of this. But that's useful, because, like, you could have ionized nebulas that you add, like, a level, like, volumetrics in the stage that you add, like, tendrils of lightning to or something like that. But kind of the way I look at shit like this is like you either jump on the bus or you risk like just fucking falling behind. So like fuck, I'm jumping on the bus, you know what I'm saying? If a new tool comes out that makes everything I do insanely easy, then I'm gonna fucking use that shit. Okay, well, we don't need distance from Earth. Oh, are you looking for names for stuff? Yeah, it's great for stuff like that. Like if you like that to me, when I've tried to like come up with stories and shit, picking out names is like one of the hardest fucking things. And like this is just like whatever, spit it out. I got it the other night. I was fucking around with it. I got it to write like a parallel, a parallel reality version of like a Bill and Ted type movie, but it was like Alex and Jess's time adventure or something like that. I got it to write a whole goddamn script, dude. Like the first probably half of a movie. I did it in like 30 minutes. And it was like, alright. Like it was better than some movies that I've seen. Like, or at least the script sounded better than some I've seen. Like, you just keep fucking with it. You just keep prompting it. You say like, okay, write the first scene, and it'll write a scene, and it'll be dog shit. And you say, oh, I don't like this part. I don't like this part. Why don't we try doing this or that? And then it'll come back with another one, and you're like, yeah, that's a little bit better. But at this one part, this character does this, and that doesn't really make sense for their character. So what if they did this instead? And I'll go rewrite it and change that. And if you do that for 10 minutes, you have a scene. And if you do that for 6 hours, you have a movie. I mean, you still have to film it and do all that shit, but the AI is going to be able to do that too. So that's what I mean when I say that you're going to be able to just ask for like a TV show and get like a TV show, but it's not an original thing that nobody's seen before. Or music. You can already do music, it's just not very good. Well, it has moments. So it's like 75% of the time it's bad. And then 25% are like, oh, this is, yeah, I could see this. Like if somebody put a vocal over this or something. Yeah, you just like say like, no, this is not good. Don't like that part. They basically get sent back in time by a mad professor type college professor that has like a side project, and he tricks them into testing his time travel device. And the AI kept trying to say that like he was saying like, yeah, come test this time travel device. And I'm like, no. He wouldn't tell them that it's a time travel device because he wants to test it on them, and he doesn't want them to like run away or think he's crazy, and he wants to test it on them to see if it works, right? And it's like, oh, okay. And then it rewrites the scene, and this time he's like, kind of sneaky and sinister and more like circumspect, and I'm like, okay, yeah, that's good. And then you it's like okay, we don't need distance from Earth. What is angular size? Angular size of the nebula in arc minutes. Okay. Yeah, that's good. We don't need distance from Earth. So tomorrow, I'll make an algorithm to randomize structs, and I'll get this to give me ranges. Like, it can also, like, for instance, when it gets done with this, I'll say, what's a realistic range for the angular size? And it'll give me a range, and then I'll just program that in as the randomization range. Here's a realistic range for the angular size value. Oh. Okay. Oh, I get it. No, I don't need that. Okay, instead of angular size, can we do size in a different unit that is not relative to Earth's position? Okay, you see what I'm telling this thing? Let's see what it does. Boom. Now we got size in light years. Okay, now what is a realistic range for okay, now what is a realistic range for the size value? $24, $10. Boom. What are the values that should be used in the type field? There's your type enumeration, along with the descriptions. This is gonna make doing shit like that, like data modeling. Forget about it, dude. This is insane. Like, this saves so much goddamn time doing it like this. It's not even. And this is great. I wouldn't have come up with this many. I would have had like, oh, you know, this one, that one, that one. No, don't get me wrong. I would probably only use like 2 of these at the start. You know what I'm saying? Like, you don't have to implement every part of the data model immediately. Okay, so now we got our type. Okay, I like it. I should have. Hang on.
So you can see, like, I could probably come up with like a reasonable data model to represent like a universe, like all the way up to universe level in like a day, just fucking around with this AI and have it be like pretty realistic. And then I can use the AI to tell me the realistic ranges to randomize all these values between, potentially even give me like probability distributions and stuff. It's serious. It's a serious tool. I want these two. These are good. Yeah, I'm going to revisit this. I might do data modeling here coming up pretty soon because I'm getting to the point where I can start randomizing skyboxes and stuff. Yeah, why not? No, I want to save. This, temp. Not have set up rights for Notepad++. But now it's super late because I got involved with talking about this ChatGPT shit. But I'm going to go to sleep. Have a good night.